Hello everybody, today I'll be going through all of the challenge questions in Edexcel's Pure Year 1 textbook, chapter 12. Okay, so our first question is from exercise 12b, and we're told that f of x equals 1 over x, and given that f prime of x is equal to the limit as h approaches 0 of f of x plus h minus f of x over h, show that f prime of x is equal to the limit as h approaches 0 of minus 1 over x squared plus xh. So this is using differentiation from first principles. So if we first find what f of x plus h minus f of x over h is equal to, so we have 1 over x plus h minus 1 over x over h, and putting the numerator of this fraction over a common denominator, we have x minus x plus h over x plus h all over h, and so we have minus h over x plus h over h, and therefore we have minus 1 over x squared plus xh, expanding out brackets on the denominator there. And so we have that f prime of x is equal to the limit as h approaches 0 of minus 1 over x squared plus xh as required. Okay, for part B, deduce that f prime of x is equal to minus 1 over x squared. Well, we can say as h tends to 0, the minus 1 over x squared plus xh tends to minus 1 over x squared plus 0, which is just equal to minus 1 over x squared. So we have that f prime of x is equal to minus 1 over x squared as required. Okay, our next question is from exercise 12f. The line L is a tangent to the curve with equation y equals 4x squared plus 1. L cuts the y-axis at 0 minus 8 and has a positive gradient. Find the equation of L in the form y equals mx plus c. So we have the curve with equation y equals 4x squared plus 1, and we have the line L which goes through the point 0 minus 8, the equation y equals mx plus c. So first of all, you know that the y-intercept is minus 8, so we can replace c here with minus 8. So our equation for L is y equals mx minus 8. Okay, and we know that the line L is a tangent to the curve, so if we solve these two equations simultaneously, we should only get one solution for x. So we have 4x squared plus 1 is equal to mx minus 8, and therefore 4x squared minus mx plus 9 equals 0. And now we know that this line is a tangent, so there's only one point of intersection, so the discriminant b squared minus 4ac must be equal to 0. So we have m squared minus 4 times 4 times 9, which is 144, is equal to 0. So we have that m equals plus or minus 12. And we're told in the question that L has a positive gradient, so we know that m equals positive 12. Okay, therefore we have the equation of the line y equals mx plus c as y equals 12x minus 8. Okay, and our final question is from mixed exercise 12. Part A says find the first four terms in the binomial expansion of x plus h to the power 7 in ascending powers of h. So our first term is going to be x to the power of 7. Then we're going to have plus 7 choose 1 times x to the power 6 times h. Then we're going to have plus 7 choose 2 times x to the power 5 times h squared. Then we're going to have 7 choose 3 times x to the power 4 times h cubed. And those are our first four terms in ascending powers of h. So, simplifying, we get x to the power 7 plus 7x to the power 6h plus 21x to the power 5h squared and plus 35x to the power 4h cubed, and so on, so on, so on. And that is our answer to part A. And part B says, hence prove from first principles that the derivative of x to the power 7 is 7x to the power 6. Okay, so our formula for differentiation from first principles is f prime of x is equal to the limit as h approaches 0 of f of x plus h minus f of x all over h. Okay, so part B, we know what x plus h to the power 7 is, so we can plug that into our formula. So we've got the limit as h approaches 0 of x to the power 7 plus 7x to the power 6 h plus 21x to the power 5 h squared plus so on and so on. And then minus f of x, which is x to the power 7 all over h. The x to the power 7 cancels, and so we're left with the limit as h approaches 0, and dividing all these terms by h, we have 7x to the power 6 plus 21x to the power 5h plus so on and so on. Now we know all the terms in this expression here will have h in it, whether it be h or h squared or h cubed, apart from this 7x to the power 6. So the limit as h approaches 0 is just going to be equal to 7x to the power 6. And that is our final answer. Okay, and that is the end of the challenge question walkthrough for Pure Year 1 Chapter 12. I hope you enjoyed, and I'll see you in the next video.